Okay, so since it's already 10:10, let's get started. Good morning, everyone. Welcome to your first tutorial of CSC D70. My name is Bo Jian, and I will be your TA for this course. As always, during this class, please always feel free to turn on your camera and also unmute yourself, because if you send your questions in the chat channel, I will not be able to see it on time. Okay, and also apparently I'm not a native English speaker, so yeah, if there's something that is unclear, so please always feel free to ask any questions. Okay. So before we get started on the announcements, might know whether anyone has any questions or concerns about the course? Anything? No. Okay, so assignment 1 has been released today, and it is due on February the 1st. In today's tutorial, we'll be talking about the first half. So the assignment consists of two sections. So the first section is the programming assignment, and the second question is on theoretical questions. Okay, and in today's tutorial, we'll be discussing about the first half of the programming assignment. And in tutorial number 2, we'll be discussing about the second half. And in the third week, in the tutorial of the third week, we'll be discussing about the theoretical questions. Okay. Any questions before going into the slides, today's tutorial slides? If no, let me just share the screen. Okay. Okay, so in today's tutorial, we'll be discussing about two major topics. So the first major topic is that we'll be doing a short review or preview of C++. I hope that for those of you who attend this class, like you have at least some background knowledge on how to program in C. And the second major thing we are going to talk about is how to write an LLVM analyze path. And of course, we'll introduce what an LLVM analyze path is. Okay, so before we go into talking about C++, might I know whether anyone has any previous experience with C++ before? Anyone? You can send your response in the chat message channel. Okay, seems that so. Yes, some people have previous. Yes, some people have some previous knowledge on C++. So, in general, C++ is just, in short, it's just a C with classes. It means that so it's like the object-oriented programming extension of C. So in today's tutorial, we'll be discussing about the following key major difference between C and C++. So the first is we'll be introducing this notion of variable reference. So in C, we always say that so we can, for a function, there's what we call pass by pointer. And here we have pass by reference. We can clearly see that so here instead of having the star, we have an ampersand here. That ampersand denotes a variable reference. And second, we'll be talking about the public inheritance. So the notion of public inheritance is exactly the same as the notion of inheritance in other programming languages, such as Java and Python. And finally, we will be talking about the standard template library, one of the primary reasons why we use C++. Okay. So let's start by talking about pass by reference first. So let us now take a quick look of this function signature foo, which takes a reference of integer a. Let us now first do a quick review of what does it mean to pass by pointer. In C, we pass by pointer if we decided to modify the value of the arguments. In this case, we might decide to pass by pointer, or maybe because the argument itself is a data structure, and the data structure is really large, and we want to avoid this overhead of copying the arguments. In that case, we might also decide to pass by pointer. However, the bad thing with pass by pointer is that so every time we want to access the pointer or the element the pointer is pointing to, we always need to take the address of it, of something, or we will have to dereference the pointer. On the other hand, however, variable reference allows us to access the variable as is. This is so we no longer need to take this pain of taking the address or dereferencing. The difference, one of the difference between variable reference and pointer is that so there is no such thing as a null reference. Reference must be initialized by a variable. Okay. So for those of you who are not familiar with C++, we have an example in the GitHub repository that is on variable reference. The second major difference between C and C++ is on public inheritance. The C++ class, in short, is just a C++ data struct with methods. And the methods are exactly the same notion to what we have seen in Java. And similar to the object-oriented programming languages that we have seen before, public inheritance allows us to leverage the members and methods of the base class. So for instance, suppose that we have a base class animal. By using the public inheritance, we can have a child class fox that inherits all the members and methods of the base class animal. And one of the reasons why we want to do this is that public inheritance allows us to leverage the same interface. As an example here, suppose that we have an interface here, animal, class animal, that has an abstract method run. We can have a child class fox that inherits from this animal and implements this method run. Okay, so this is on public inheritance. And similar, again, so very similar to what we have seen before, base class pointer or reference can point to any child class instances. And in order to get this runtime information on what this base class pointer or references is pointing to at runtime, we'll do dynamic casting. So dynamic casting allows us to downcast the pointers and or variable references to the child class types. Again, so for those of you who are not familiar with C++, there is another example in the repo on public inheritance. And finally, we'll be discussing about the standard template library. The standard template library is one of the primary reasons why we decide to use C++. So if you have programmed in C before, hopefully, so you could agree that it's very painful sometimes to implement like data structures such as lists or dictionaries that are very commonly used. The good news is that so C++ has this standard template libraries that provides very easy access to the common data structures, such as a vector, which is a list, Python list-like data structures, or an ordered map, which is Python dictionary-like data structures. And the way we are going to traverse through the list or the dictionary is by using what we call iterators. So let us now have a look at this a vector container that we have created, A, which is an array, unsigned integer array of 1, 2, 3, 4, 5. So by traversing through A using iterators from the beginning to end, we can have access to every element of A by dereferencing the iterators. Okay. Yeah, again, so we want to highlight it. So dereferencing an iterator, just you can like think of an easy way to think of it is like an iterator is just like a pointer, and dereferencing an iterator gives you the reference to the stored elements. Okay, and yeah, we also have an example in the repo on this, on how to use the STL container. Before we proceed to the next section, I know whether anyone has any questions or comments.
Just wondering if these slides are going to be posted online?
Yes. So the slides are posted, will be posted. It's already posted in the GitHub repo.
Okay, thank you.
So yeah.
May I ask a question?
Sure, go ahead.
So like you have public inheritance in C++. Is there like private inheritance or what? What does a public mean?
Okay, so so this is a very good question. There is private inheritance. So, but yeah, to avoid the complication, we avoid. So yeah, we avoid. So yeah, we skip the discussion for now. But yeah, so to answer this question, there is indeed private inheritance. But so the thing with private inheritance is that, let me see whether. So suppose that you have, yeah, so to answer this question, can I see the board for now? Suppose we have something like class A, which inherits, which does private inheritance rather than public. Private inheritance, we know that so public inheritance models and is a relationship. What does it mean for it to model and is a relationship? We said that, so, for instance, we said that so class fox inherits from class public, inherits from class animal. Then a fox is an animal. So public inheritance models and is a relationship. Whereas private inheritance, it models has a relationship. So now that you know that so a model has a relationship, what is the equivalent way of using this private inheritance? Well, you can directly remove here. You can, instead of doing the inheritance, you can directly declare B as a member of A. Right? So this is why, like, in most cases, people in C++, people usually use public inheritance. Does this answer your question?
Yeah, I see. Thank you very much.
Yeah. So there is indeed private inheritance, but yeah, to avoid this, this might be too complicated for those of you who are not familiar with C++. So yeah, in the scope of this class, we'll be only dealing with public inheritance, because it allows us to derive multiple child classes from the same interface. Other questions? No?
Excuse me?
Yes.
For this course, do we need to know the smart pointers?
What?
Smart pointers.
Smart pointers? No. No.
Okay.
Yeah, I mean, smart pointers is also part of as the standard template library, but yeah, in this course, we'll be mostly dealing with the containers of the.
Okay.
You have to know how to use the containers of the standard template libraries.
Okay. Perfect. Thanks.
Other questions? Yeah, so back to the question of your colleague. So the tutorial slides has already been posted. So if you check out the GitHub repo, you'll see that so it has a README file in this tutorial folder. And when you click on the title, you'll be going to the tutorial slides. Okay. Other questions before we moving on to the second part? Okay, so let's move on. In the second half, we'll be talking about how to develop an LLVM analyze path. And to do this, we'll be first talk about, so first, what is LLVM? And second, what is an LLVM path? And third, what is an LLVM analyze path? Okay, so first question, what is LLVM? So LLVM, which stands for low-level virtual machine, is the state-of-the-art compiler framework for research purposes. It's similar to GCC. However, because it's modular and well documented, so this is why you can see it, So this is why you can see it very commonly used in research or production works. Okay, so in this course, we'll be mostly dealing with LLVM, the LLVM compiler infrastructure. Okay, so during today's lecture, today's first lecture in the afternoon, we'll be talking about lots of compiler optimizations, such as common sub-expression elimination, constant propagation, etc., etc. So one thing that you will notice for those compiler optimizations is that they are invariant with respect to the programming language front end and hardware backend. So what does this mean? So let us suppose that we have, let's say we write a program like this. We can clearly see from this sequence of statements that C is just A. However, in this, if we calculate C in this way, then we are doing one extra computations here, minus, right? To avoid this computation, apparently, so we can avoid this computation, right? So does this matter whether we are programming in C, C++, Java, Verilog, does it matter which machine we are working on? Does it matter whether we are working, for instance, on some MIPS architecture. Suppose that we are working on our mobile platforms, or we are working on our personal computers. No, it doesn't. Okay. So apparently, as people have been working on this, like trying to optimize their programs, what they observe is that so lots of optimizations, they are invariant with respect to the programming languages, which we call as front end, and the hardware platforms, which we call as back end. Right? So because of this, based on this observation, people introduce this notion of intermediate representation that serves as this name suggests, is an intermediate representation between multiple programming languages and target machines. And what we want to do now is that so we want to have optimization passes that act on those representations to optimize them. Okay. So the intermediate representation has basic syntax very similar to the assembly language that you are familiar with. So we categorize optimization passes into analyze and transform paths. Analyze passes gather information about the program itself, whereas transform passes mutate the program. Why such an isolation exists? Well, the reason is because, so first is because for better readability, of course. So we want to split up this, the passes that analyze the program and the passes that do the actual work. And the second reason is because so very frequently we'll see that so multiple passes require the same piece of information. So for instance, suppose that so we can have multiple transform passes to try to optimize functions or loops, for instance. And you will see that so very frequently they require the same analyze path. For instance, you have an analyze path that says loop info that tries to gather all the information of the loops in your program. And you will have multiple passes, for instance. Loop on row, for instance. Loop vectorize, for instance, that try to rely on the same analyze information. Okay. Yes, please. Questions? Is there a question? No? Sorry, I saw someone raise their hand. Okay, so yeah. So as we have mentioned, so such isolation exists in order to avoid redundant analysis. Okay, so now that we have talked about this notion of analyze paths and LLVM analyze paths, we'll be discussing about how to write an LLVM analyze path. And before we go into this topic, may I know whether anyone has any questions or comments on the LLVM analyze path? Is everything clear? Yeah, make sure you ask now because you'll be dealing with this in your first assignment. No? Okay, so back to the question. So how do we write an LLVM analyze path? So to answer this question, we need to understand the following. So we first need to understand the notion of an LLVM modulo. That is, so how does LLVM translate our program? into intermediate representation. And the second question is, so how could we traverse through the program using iterators? And the third question is, so how do we get more information from the iterators by using downcasting? And finally is like, how do we leverage the path interfaces that LLVM provides to us? Okay, so let's first take a look at the first question. That is, so what is an LLVM modulo? So when we develop our programs, usually our program consists of multiple files. Each file has multiple functions, and each function has multiple basic blocks, and each basic block has multiple instructions or statements. Okay. And what LLVM does is that, so each file will correspond to a modulo. Each modulo will have a list of functions. Each function will have a list of basic blocks, and each basic block will have a list of instructions. Okay. And to traverse through the modulo, for instance, what we'll do is very similar, exactly the same as what we have seen previously on how do we traverse through a standard template library container. That is, so we leverage iterators and traverse through from the beginning iterators until the end. Okay, so this is how we traverse through an LLVM module, the functions of an LLVM modulo by traversing through its iterators. And similarly, we can traverse through all the basic blocks of a function by traversing through the begin iterator of the function until the end iterator of the function. And similarly, we can traverse through all the instructions of a basic block by traversing through the begin iterator of that basic block to the end iterator of that basic block. Okay, so think of this as a list of instructions. And every time you want to traverse through the list, you use the iterators by going from the beginning to the end. Okay. So now the question is, so how do we get more information from the iterators? That is, so let's suppose that, as we have mentioned before, by traversing through the iterators of a basic block, we get a list of instructions. So suppose that now we have an instruction. How do we know whether the instruction is a binary operator, for instance, or a unary operator, or even a return statement? So we use downcasting. So the idea of downcasting is that, so downcasting allows us to retrieve more information from the iterators. Again, very similar to what we have seen in the previous slides on dynamic casting of C++. As is shown in this example, where we can do dynamic casting at the runtime from an instruction to a call instruction. And if the casting is successful, then we output that I'm a call instruction. Okay. And finally, on the path interfaces. So LLVM provides us with path interfaces that allows us to directly leverage by doing public inheritance. It has path interfaces that targets, for instance, a modulo known as a modulo path that you will use in the first assignment. And there are also other path interfaces, such as a function path or even a loop path. So how to use those interfaces? Well, so as we have mentioned before, we do public inheritance. The path interfaces of an LLVM, as an example, the modulo path interface of LLVM has this abstract method run on modulo. And your job in your first assignment is to inherit from this interface and implement this run on modulo method. Before we go into today's review, may I know whether anyone has any questions?
Sorry, just quick clarification. So when we're writing code, we're just going to be writing C++ code. I don't see, is LLVM like a library, or is it, where does that fit in with the C++ code?
Yeah, so LLVM is like a library. Think of this, think of it as a library.
Okay, gotcha.
Yeah, you'll be writing C++ code that involves the LLVM library. The path interfaces, for instance, comes as part of the LLVM library. Does this answer your question?
Yeah, that answers my question. But I was gonna say, like, what exactly is a pass?
So,
pass.
So do you understand, is the notion of intermediate representation clear here? Why do we need, first, why do we need an intermediate representation? Is this notion clear?
Yeah.
Okay. So a path or an optimization path is what acts on those intermediate representations to optimize those representations.
So in your case, in the example you'd shown, it's basically taking out the two operations and just going straight to C is equal to A. Would that be a optimization?
So in the examples that we have talked about previously, the job of the optimization path is to eliminate this, replace this statement with C equals to A.
Okay.
So this is what a path does.
Okay, that makes sense.
And you will be doing the same thing in your first assignment. Other questions?
Yeah, I had a question.
Yes.
Going back to that slide with the run on module.
Run on module. Okay, here.
Yeah, so that one. So the purpose of this analysis pass is to figure out what exactly, like what does run on module return? Like what's the meaning of that Boolean value?
Oh, so the Boolean value. Okay, so this is a good question. So the information is not the Boolean value, what the Boolean value returns. So if you check the documentation, that Boolean value is used to indicate whether you have modified the modulo or not. Okay, so it's not used for returning, it's not used for storing the analyzed information. We'll be talking about this in the next tutorial, but so the information will be stored as class members. The Boolean value it returns indicates whether the path has modified the module or not. Of course, if we are dealing with analyzed path, you can expect that so the Boolean value return will always be false to indicate that so we have not modified the module.
Okay, cool. Yeah.
So yeah. I'll just blah 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 module path. The info will be stored as class members. And yeah, in terms of this method, run blah, blah, blah. This Boolean variable tells you whether you have modified your target, your optimization target or not. So as you probably expect, if you're working on function path, then this Boolean variable tells whether you have modified this function or not. Right? But it does not store the analyze information. The analyze information is stored here as a class member. Does this answer your question?
Yeah, that's perfect. Thank you.
Any other questions? No? Okay, so if there are no questions, then we are going to talk about, we are going to do a short review of today's tutorial. Okay, so in today's tutorial, we start by a brief review or preview of C++. So we talk about this notion of variable reference, where we said, so a variable reference is exactly the same idea as a variable pointer, but you can access a variable reference as is, which is more convenient. In fact, as we can see from this path interface, this run on modulo gives you a reference to the modulo. Means that so every changes you make to this modulo will be reflected on the modulo itself. It's not a copy of the modulo. Okay. We talk about this notion of variable reference. We talk about this the notion of public inheritance, which is exactly the same as the extends relationships that we have seen before in Java, for instance. We talk about the standard template library, which includes vector, which is a Python list-like structure, and an ordered map, which is a Python dictionary-like data structure. And how to traverse through those standard template library containers by using iterators. Okay. And then we talk about how to write an LLVM analyze path. Okay. We discuss about the notion of intermediate representation, or IR for short. So we said that so people introduce this notion of IR because they observe that many optimizations are invariant with respect to the programming language frontend and the target machine's backend. Okay, and we talk about the optimization passes that act on those IRs. We said that so optimization passes can be further categorized into analyze and transform paths. And finally, we discussed how to write an LLVM analyze path, which you will do in the first assignment. We talk about this, what is an LLVM modulo and how do we traverse, which is a list of instructions. And how do we traverse through the modulo using iterators? How do we do downcasting, similar to, how do we do downcasting to retrieve more information from the iterators? And finally, the path interface that we'll be using in the first assignment. Okay. Any questions?
Excuse me, I have a quick question.
Yes, please.
Yeah, for the IR, do we use 3 address code or the SSA?
3 address code. We'll be using SSA.
Okay, perfect. I see. Thanks.
Other questions? No? Okay, so if there are no questions, then your homework assignment for today is to implement the first half of the program assignment of assignment 1, which is so to gather some information about the functions in your program. Okay. And yeah. So the assignment has been released in the GitHub repo. So check out the GitHub repo and go to the assignment folder for the startup code. Okay, and again, so click on the title for the assignment handout. Any questions? So if there are no questions, then thank you all for coming. Yes, especially since this is Monday morning. Yeah.
Sorry, quickly, for the assignment, it says search the folder for to-do items. Is that the function info folder or
Both folders.
both folders? Okay.
So this is the second part of the assignment, and we'll be talking about this. Yeah, we'll be talking about this in our next tutorial.
Okay, thank you.
Yeah, I might have missed some to-do items in the because I have added because there's no like those to-do items mark in previous offerings, and yeah, students complain about this. So I added those to-do markers like this year. Like hopefully I didn't miss any to-do items markers, and yeah. Other questions? Okay, so if no, so thank you all for coming. That's all I have for today's tutorial.
Thank you.
Thank you very much.
Thank you.
Thanks.